some of the technology or the previews shown in here don't actually exist yet. That's what Microsoft is planning for the Kinect and hoping to get to. But like you can see, there was a lot of pretty cool stuff. I don't know, have you guys watched Minority Report? Yeah, Tom Cruise, 2000 and something, I don't know. You got a lot of hand waving, bringing things forth, pushing them back and stuff like that. That's what Microsoft wants to do with the Kinect. And then another video of what is going on right now. Okay. There's a reason that they actually want you to say, make sure that you have enough playing space, because if you don't, that's what's going to happen. So, right. Okay, so to do any kind of Kinect programming, this is the kind of stuff that you'll need. You'll need a Kinect sensor. So as I mentioned, there are two sources. There are two choices at the moment. There's either the 360 Kinect, which is this one, or the Windows Kinect, which has the near mode for closer, closer programming. Then, then you need the Visual Studio IDE and the Kinect SDK. You can download that from Microsoft. Then, in terms of PC hardware requirements, you need a 32 or 64-bit processor, and the rest of the stuff which you can read down there. Okay, these are my sources for some of the stuff, YouTube and so forth, and then resources. Okay. No problem, let's just move on. Okay. So, like I mentioned at the beginning, I've got a couple of demos, that's why I was going so fast. I want to go through a video or camera demo, the depth demo, that's using the infrared camera, and then skeleton tracking and speech recognition. So, let me get around. Oh yeah, and I'll also be asking for a few volunteers because I don't want to be standing up all the time. Wait, before I get around to this, let me show you what happens when you plug the Kinect in. Okay, so at the moment my Kinect is plugged in, and you can see Microsoft Kinect over here. When you expand that, you've got all the particular devices or all the particular applications which the Kinect comes with. So you've got the microphone array, the audio array control, then the camera, then the device itself, and the security control. Okay. I think under, let me just see, I haven't actually done this before. Okay. Down here is where you get the Kinect USB audio. Like I said, it's a USB device. It's actually pretty similar to any other pen drive, though there is a difference. Okay, So when you get around to developing, I'm not going to be doing live coding because there's a lot of code, but when you get around to developing a Kinect application, you start it like any other Visual Studio program. So you start the project up, and then you go to make a new project, so forth, and then what you do, and what I'm doing in these cases are window WPF forms, okay? I think it's a bit similar to Silverlight. It's XAML programming as well. Okay. So what you need to do is when you install the Kinect SDK, it comes with a couple of references. So depending on what you're doing, you need to link the references up. There's Coding for Fun, which is quite a good website. They do a lot of other Microsoft softwares as well. So they do Kinect, Windows Phone, and Xbox, and so forth. So this is their library. You don't need this library if you're amazingly crazy and you want to do all the mathematics yourself, which I don't want to. Okay, and then you've got the Microsoft Kinect as well, so you just add those references. Okay. Then, like I said, this particular program is just an RGB camera program. So let's go through it. Yeah. Okay. Is the Zoom okay for everyone? Okay. So let's go from the beginning. Okay, so you've got your Kinect sensor and you need to register to that. So you've got Kinect sensor and you can name it anything else you want, so sensor. That's what we're going to be using all the time. Then when you load the WPF form, what you can do is straight at the beginning you can search for sensors. So that's what this part of the code does. Basically it's searching for sensors and then checking if the sensor count is above 0, sorry. So if it's 1 or more, then that means we can do something. So in this case, this is not needed, but it just helps me to know that, okay, we've got a sensor attached and everything is fine. So it's going to show that initializing message box, okay. Then we pick the first sensor, which is sensor 0 down here, and that's what we're going to be using. So if sensor status is connected, then we can sign up to all of the kind of streams. So, like I said, it's got a RGB camera, it's got a depth stream, that's the infrared. Then it's also got skeleton tracking. With skeleton tracking, what happens is that it uses algorithms based on the depth stream to calculate where a person's head is, where a person's hand is. I think it's up to 26 body parts. Okay. Then you've also got the audio stream, which is here. Okay. So that's the audio source. So that shows you all of the 4 particular streams that you can sign up for. In this one, you don't actually need these 3 because it's just a video basically. Okay. So then you do the all frames ready, and it's a new event, and then sensor starts. And you start the sensor. Okay. So what we're doing over here is basically, you know how a video is built up, right? It's frame by frame. So you've got the first frame, and then you change the picture, and so forth, like 30 frames per second, basically. So what we're doing over here is we're building the picture. What happens is we don't want to cause any exceptions if there are no frames in the camera. So if it's null, we just return, we skip it, and we move on to the next frame. Okay. Then you create an array of pixels, and you copy what is inside color frame to pixels. Okay. And this is a bit complicated now. The stride is, how should I explain it? It's basically, you've got blue, green, and red, and then you've got an empty package. So it's four packages per pixel, let's say. And what you need to do is you need to be able to tell the program that when it finishes reading the first pixel, how far forward it should go to move on to the next pixel. So if you mess this up, you're going to end up with a very weird looking picture. That's basically what happens. So you've got, so you've got the pixel width. In this case, we're going to be using the color frame width, then the height, which is also the color frame height, so that I can see what's happening. Okay. Then double X and it's dots per inches, DPI. So DPI X and DPI Y, and in this case, we're just doing 96, 96. Then the kind of format you want, there are different formats. You can do BGR32, that's blue, green, red 32. Then a lot of different ones, you can see them all here. Black and white, so forth. Let's just leave this as it was. Okay. Then the next thing is the bitmap colors, which in this case, we're not doing anything with bitmaps, so we're just going to leave that as now. Then pixels, which is the array that we created, the array of pixels, and then BGR stride, which is from here. So that's what it stands for. Does anyone want to volunteer? It's just a walk around. So, like I said, you're going to see initializing. This is not important, but it just helps me to know that everything is working the way it should be working. Then you click on OK, and we get a problem. Let me just see what this is. No, just anyway. Oh, right, yes. Thanks. Yeah. It wasn't doing anything with the audio source, so that's why we missed it. Okay, so like I said, it's just a normal video camera. So at the moment, only the RGB camera is working, and none of the other things are working. I don't know. You'll also get to see. Let me stand up for a second. Turn this way. You can see that the infrared projector is on, and you can see that it's not, like with sonar and radar, it's just one massive beam being projected. But with this one, it's a couple of dots, and all of the dots get that night vision picture which I showed before. All of the dots get projected with the X, Y, Z components and so forth. Okay, so back to here. And then I also mentioned that there's a motor inside there. So you can get the motor to go up and down. You'll see the Kinect moving by itself. At the moment, I've done it to do an angle of 5 every single time you click it. So it's going to go up and down 5. And to make sure that you don't wear out the motor, there's a limit to the number of times you can access the motor. I think it's 15 times every minute or something like that. I'm not too sure about that. Okay, thanks. Okay, so that's that one. So you'll get to see that it's more or less the same thing again. The references are all the same here and here, micromechanics and coding for fun. Okay. Then this is a bit of a longer, more complicated project, but it works with the depth camera. Okay. So you've got 3 floats over here, constant floats. There's maximum depth. So the Kinect is going to be able to sense up to 4 meters away, then up to 0.85 meters close. Then there's also a depth offset, which is the difference between the two. Okay, this time we're making use of the depth stream, so that's over here this time. And resolution is 320 by 240, that's 30 frames per second. And we need to enable this because well, you'll see at the bottom I'll do something so that I track the person a little bit as well. Okay, so sensor start and so forth down to here. Okay. So again, this is very similar to the other project. You just compare it quickly. Down here. So in this project we were working with color frame, just the color camera. But in this project we're working with depth frame, so it's just a replacement of that. Okay. So again, if any frames are not present, we're just going to skip them. So we just, if that frame is equal to now, return. Then this time there's a function. So this time we're going to be working with a function instead of just doing a pure output of copying the pixels from the color frame. Okay. And then stride, this is stride again, and depth frame times 4. There's always going to be times 4 when we're working with this. Okay. So this is the function generate colored bytes. So basically what this program is going to do is, depending on how far away you are from the projector, it's going to color you in a different color. So if we'll go down a little bit, you set up the constant integers. So there's a blue index, green index, red index, BGR, like normal, 0, 1, 2. We're not working with the empty index, so I just commented that out. Doesn't matter. Okay. So this is a double for loop, 2 variables. There's a depth index and then there's a color index. Okay. So the depth index is calculated. It basically helps us calculate the player number and then the depth as well. Okay. I don't want to go too far into this because I'll start making a few mistakes as well. It's kind of weird and complicated. But okay. So what we do now is we've created the pixel array up here, over here. And we start coloring depending on how close or how far the object is. So you've got your pixels color index, which is the calculation, and then plus the blue index. So basically you're telling it, okay, in this case, this is blue, this is green, and then this is red. Blue, green, and red, like normal. And for anything that is closer than 0.9 meters, so anything between 0 and 90 centimeters, is going to be blue, completely blue, because it's only, we're only adding integers to blue. There are still not 0 and 0. Okay. Then if anything is between 0.9 and 2 meters, we're going to make it green. And then if anything is further than 2 meters away, we're just going to make it red in this case. Okay. So again, I need a volunteer to just walk by. Anyone volunteer?
If you don't want
just, yeah, it's just a walk around. So, okay, so go closer to the camera. So you can see that it's just changing the colors depending on how close everyone is from the camera. So when he starts to go further back, he'll start changing into blue and then into red, depending on how far back he goes. Okay, go a little bit closer. Yeah. So you can see, wave your hands around here if you feel like doing it. Okay, thanks. Edward, since you're volunteering, can you sit down here because I'll just use you for everything. Everyone else is afraid of the red camera. So now what we're going to do is, instead of doing it blue, green, red, the whole picture is going to be black and white. So before you do that, you need to calculate the intensity. The intensity is basically a function to calculate how close the person is. Again, it's the same kind of idea. Okay. So what you do is you return a byte, and it's well, you can see it from here. So it's 255, which is the maximum for any color, minus the function offset basically. So 255 times max distance minus min distance and then 0. All of that divided by the max depth distance, which was calculated at the top, up here. Okay. So let me run it again. Okay. So like you can see this time, because the room is kind of big, everything in the back is black, but if you walk back and forth a little bit, you'll see that his color changes. The closer he gets, the less the intensity, so the whiter he gets. Yeah. Okay. Yeah. Thanks. Okay. Then now, like I said at the beginning, we're using this, the skeleton stream enabled to track the players. So this part of the generate colored bytes function, which is give me a second. Okay, here. This part. What we do is we find players. So if the camera detects anyone who seems to be a human being, it's going to calculate him to be a player. So each player gets assigned a number. Maybe player 1 is 0, 1, 2. It's not like that, but for a human being, we will say we call it 0, 1, so. So if I uncomment this part of the group and run it again. Does anyone else want to volunteer for this? Okay. Okay. So already he's changed into gold because the camera has detected him to be a player and he can walk around now. Edmund, care to join? There we go. So now you've got 2 players walking around, 2 gold people. Okay. If that's anyone else joining, what's going to happen is that it shouldn't work. Let's see, I haven't ever had 4 people because I'm just 1. Oh, it does. Okay, so now you've got 4 players being tracked at the same time. Each of them can move around in different things. Okay, it seems that's how has gone too far back. Okay, so this is just a very simple camera manipulation. You get to see the track players and yeah, that's it. Thanks. Okay. Now this is slightly a bit more entertaining. With this project, augmented reality, everyone has heard of that a little bit. You point the camera at something and it projects something else there and so forth. Okay. So again, it's the same references. It's the same references. You've got your Kinect from Coding for Fun, and then Microsoft got Kinect as well. What I did was different people at different sites, so I also added a tab down here so you can change the size. You can set the size that you like the object to be at. And then, okay, so let's go to the code itself. This is pretty simple. What we do is you've got your image. So you've got, okay, sorry, I need to go back to here. What you've got is you've got an image down here. You've got the image 1. Resolution size. So you've got your image 1, and on top of that, what you put is the canvas. So the canvas has the different objects, and then the image is just a normal camera output. Okay. So you've got image, you've got a head, you've got something for the left hand and something for the right hand. Okay. And then when the person walks around, the Kinect tracks his head, his hand, and so forth, and replaces that with this. So again, it's all the same kind of stuff. Kinect sensor. Skeletons. Okay, so what you need to do is you create an array of all skeletons, called all skeletons, and what it does is it's the size of the number of skeletons that are available. So for the example that we just had with 4 people walking around, it would be a size of 4. Okay, but over here what we've done is, instead of it automatically finding, we set a default. So we've got a constant integer called skeleton count of size 6. And that's what the size of all skeletons is going to be. So again, like I said, in this case you need the color stream because you're doing the RGB manipulation, the RGB camera. Then you need the depth stream because it needs to calculate where everyone is and so forth. And then a skeleton stream. Okay, we'll get around to it. So again, this is the exact same copy from the first sample that I showed you. This sets up the image of the video camera going. So I don't think I need to explain that. Then again, if anything is missing, you just skip it. Okay, sorry, not that. This is okay. So what you're doing is you're finding the first skeleton inside the tracking group. So maybe you've got 4 people. The Kinect, I don't know exactly how it works with the algorithms, but it'll decide who the first person is. This is a program that I made myself, so I wasn't able to sort it out to track more than one person. I'll get around to doing that. So okay, let's get down to the function itself. It's just a simple link function from Zubov. Yeah, he calls us something. Okay, so you've got skeleton first, and it's equal to from all skeletons select S blah blah blah, and it's the first or default. Okay, so basically the first skeleton that the Kinect is able to track fully is going to be the item or the skeleton that the Kinect will return. Okay, so return first down here. Then if first is null, then we're going to skip. I should have explained this at the beginning. This particular function is repeated all of the time. It's repeated 30 times a second. Okay. So what happens is that if in the first frame it doesn't find anyone, it's going to skip it, and then it's going to keep on searching until it finds someone. Okay. Then we've got another function down here called set position, and what it does is it takes the item, so the image, so let's call this head, it takes that image and it sets the position basically. So the image is called head, and the joint needs to tell it what kind of joint it is. So the joint is a head. Okay. Like I said, we've got different kinds of joints. I'm not going to count this, but I think it's 26. So you can, let's say if it's an ankle, if you want to track the ankle of the person, I don't know why you want to do that, but okay, you've got ankle left down here. Then you've got head and hip center, hip left, and so forth. So that was just head. Then you've got the left hand, which is hand left. Then you've also got your right hand, which is hand left. So what happens with the set position is, this particular function is from the coding for fun reference. Like I said, I don't want to be calculating all of the mathematics myself, it's too much. So what you do is the joint, you scale it down to the size of the image. So in this case, we're working with a 320 by 240 size image, like I said at the beginning. And then okay, so you can float the maximum skeleton. Basically, it's like, let's say you want the person to, okay, so the person is going to act like a cursor. Let's say my hand is the cursor on the screen. You don't want it to just fit inside a particular box. So if you change it's basically a ratio. If you change the ratio, what can happen is that when I move to the left, it'll go all the way down to the left, and when I move to the right, it'll go all the way down to the right. At the moment, I've calculated this a little bit, so it's down in the same image size. Okay. Then let me stop talking around this. Okay. Well, with this, there's a size changing stuff. There's the tab down here for changing the size of everything. I didn't get it. Go away. Okay. So this is just normal size changing stuff. You can change the size. What I did is the head can't be below 39 and it can't be above 201. No one has such a big head, no one has such a small head, and so forth. Okay. And the same stuff for the rest of the items. So does anyone else want to walk around? Okay. There we go. So, like I said, I did this myself. But the head is supposed to be on top of the head and so forth. Yeah. Or a little bit closer, I think. Okay. So you can wave your hand around, do stuff, and they'll follow you around. What I'm planning on doing is, like I said, enabling this for 2 people. Okay, thanks. So, like I said, no, actually, stay. Don't worry, stay around. You can set the head size a bit. Let's see, make it 50 by 50. You can set that. It's too small. Give them a massive head. There we go. So, there we go. Okay. So for the rest of the stuff. Then there's also the take snapshots or picture, take snapshots button, which I forgot to explain. Basically what happens when you click this is it takes a picture of what the person is actually doing. And that's here. So you get to see what Alpine was doing at that time, and you can laugh and listen to this as well. Look at all these weird poses. Okay, thanks. Okay, so that takes snapshots. I forgot to explain that. What happens is that okay, this is a counter. Basically what this part of the code does is it makes sure that we don't overwrite anything that is already there. Because we want to be able to laugh as much as possible. We don't want one single picture. Okay. So if a picture of that name already exists, then you skip it. You add one to count and so forth. Okay. Now what you do is you take the bitmap source, you create an image, and you cast whatever is in image source at that particular moment. So image one source, you cast it as a bitmap source. So a bitmap source, you can save that as a JPEG, as a PNG, GIF, and so forth. Okay. So in this case, we're using a JPEG encoder, and the quality level, you know that with JPEGs you can set it from 100 to 0, depending on how much quality you want. And then you save it and so forth. This is the standard save stuff for a bitmap or a JPEG, I should say. Okay, so I haven't had any questions so far, so I think I'm doing fine. Okay. Then with the speech recognition, again, it's the same kind of idea. So you add the references. This time you need the speech as well, which is, okay, let me explain from the beginning. If you want to do speech recognition, you need to install the Microsoft Speech Engine, which you can download from MS again. And when you install it, depending on the language that you install, it will come with like a database of words that can be found or recognized, I should say. Okay. So, okay, you need the Microsoft.speech audio format and then the recognition as well. This helps you to save, and then this helps you to recognize what is happening. Okay. I found a more efficient way to find the sensor. With the other method, what you can do is you can have more than one sensor. But then with this method, it only picks the first sensor that you've connected, okay? So you've got your recognizer info, which we're going to call RI, and you make a function. There's a standard function for finding the language installed as well. So that's down here. Okay. So what it's going to return is it's going to return the speech recognition engine, basically the name of the speech recognition engine. In this case, I think I have the US version, English US. Okay. But what you can do is you can actually install different ones as well, and then when you do this function, you can add a choice. So the user can select what language they actually want to be recognized. So let's say I want French to be recognized. I'd be able to select French or German or English, depending on what you want. Okay. Then back to the top. Okay. Then Kinect audio source, we'll just call it source, and speech recognition engine, SP, and then you need a stream as well. You'll see all of this here. So SP is going to be equal to the speech recognition engine, which we just found, and RI, which was what we called it up here. So the recognizer info, and the ID. So what happens is that you need to tell the program what particular language you're using. Like I said, you can select different languages, but in this case, it's automatically set to use the language that you installed first, which is English. Okay. Then what this program does is it's working with colors. Okay. So you get to say 3 different colors, and it'll tell you if it recognized what you said and how well it recognized it and so forth. So you build your grammar database, which is the different words that it has. So in this case, we've only got 3 words: red, green, and blue. And then you append it down to gb.append. So from here. Okay. So the variable gb is equal to new grammar builder, and culture, again, culture is from what you installed. So in this case, we're using American again, American English. Okay. Then gb append colors. I'll put a footnote down here. Okay. And this is not so important at the moment because we're only using that particular installed color. I mean that particular installed speech entry, which is the American English as well. Okay. So then you load the grammar and you create 2 different event handlers. So there's the speech recognized and the speech recognition rejected. So if it recognizes, it should do something. If it doesn't recognize, then it should do something else, basically. The Kinect can actually also guess at the word you're trying to say. So let's say I say, I don't know, some weird word, and it'll try and estimate what word you're trying to say, and then it'll be able to move on. But I'm not using that over here. It complicates it a little bit. Okay, you need to make it as a thread because I don't know. I think it's an error from Microsoft. This is still a little bit early, but what happens is if you don't make this if you don't put the audio stream as a new thread, it won't work at all. The program will run and everything, but it won't be able to do speech recognition. I think that's a little bug, but I'm not sure. We'll have to ask sometime. Okay. So we set our source to the sensor. Again, you've got your, from the beginning, Kinect sensor down here. So we set the source to the sensor audio source, and then you've got different choices. So for speech recognition, I was reading up, and apparently it's better to do echo cancellation none. So to turn off echo cancellation. Echo cancellation means basically if it hears the same voice more than once, within like consecutive seconds or something like that, it'll cancel out all of the other ones. So it's better to turn it off for speech recognition. And then also to turn off gain control. Gain control means the microphone turns itself up or down depending on how loud the voice is. This is standard stuff as well. I can't really change it. But okay, what you do is the stream is set to the same audio source, and then you've got the encoding formats, and we're going to be using PCM. There are different ones, and let's just see what there is. I can't explain this. Okay, so PCM, and then let's go down to here. So the samples per second, and you can set that to 32,000. It's basically the quality of the sound. Okay, so the reason we're going to make it small is because this program actually saves. If it doesn't recognize a word, it's going to save it. So we'll make it small so not to waste too much space. Then the bits per sample, so 16 bits per sample. The channel count, you can say 2 channels, 3 channels. It's got up to 4 channels because it's got 4 microphones. Then 3,200, which is the average bytes per second. Blocker line, I can't explain that. And then the format for the specific data, which is now. You can play around with this as well. Let's say you want to change someone's voice, make the voice a bit high pitched, low pitched, stuff like that. You can play around with this part of it. Okay. Then what you're going to do is, this program is not like you press start and then it listens. What it's going to do is it's going to listen continuously. So if you say a color that it knows, it's just going to say, okay, I found the color, or I recognize the word, and so forth. So you set the mode to recognize multiple. There are different modes, I think single and multiple. So like I said, if you want to do press start and then say a word, then you set it to single. But if you want to listen continuously, then you set it to multiple. Okay, let's put this into Xbox programming. What happens is that, okay, the Xbox, when you connect the Kinect to it, it's listening continuously. So you can sit back and you can actually tell the Xbox, you just say Xbox, once it recognizes that you've said Xbox, so like let's say my mom is calling me and she says William, once I know that she's mentioning me, then I start listening to everything else she's saying. So let's say she says, let's say I say Xbox play, then it will go to the play menu and you can decide what you want to play. So you can actually say something like Xbox play Avengers, which isn't out yet, or search for Avengers, and it will go to IMDb and search for the thing. So it's able to recognize what you're saying, and it's not like, okay, let's go back to NUIs, no learning curves. It's not like I have to say hello, hello. I don't need to teach the Xbox how I speak. I can just speak to it and it should understand me. Okay. Too much talking. Okay. So if it doesn't recognize, so like I said, there's the event for if the speech is rejected, if it doesn't recognize. In this case, I've set it to say unrecognized, speech unrecognized, or I should say word unrecognized. And then if E results, so if the E is basically all of the things that it's recognized, all of the things that it's able to recognize. So if it's set to, if it's null, then it will dump basically it will save that particular word that we just said. So let's say you're making an application where you want to teach children how to speak or something like that. Let's say 1, 2, 3, 4, stuff like that. What you can do is you can set the sensitivity, or it's actually called confidence down here, and you can set it to say that, okay, if it recognizes a word, but the confidence level is something like less than 0.8, the confidence level is basically how sure the Kinect is of what you said. So you can set it from 0 to 1. Okay. So if, let's say, the confidence level is below 0.8 or something, you can tell the program to save it, and then the parents can later on come and see, oh, my child tried to say 1, but he said button or something weird like that. Okay. So what happens is that if the word is unrecognized over here, then it's going to dump the audio. Let's go down to that function straight away. That's down here. So again, it's similar to the snapshot idea. If the file ID, if the file name already exists, just increment it by 1. And then what you do is this audio. This is the inbuilt function for saving a particular audio file. So audio.write wavestream file. Okay. And what you've done over here is you've told it what kind of audio format you wanted to save as. So you can change that to MP3 and any other audio formats. I'm not sure which other ones exist. Okay. So let's go back to okay. So then if it does recognize the word, what it does is it's going to print a message box, and it's going to say, okay, the word was recognized, and it's going to tell me which word it was. So that's eResult.text. Result is basically the word that it's saved. So you've got alternates. So maybe green and lime green are alternates of green, so forth. Then audio, confidence, that's I've already explained that. The grammar, I don't know what some of these are, but so forth. You can play around with this. Text, okay. Then it's also going to print the confidence level. So if it's very sure the word is going to print something like 0.9, if it's not so sure, if it's not so sure, it will try and save it, and then you can play back the word. Okay. I need a volunteer again. Okay, while someone is deciding if they want to come forward, what happens is that, like I said, it's going to print the particular kind of language that they're using. Okay, so thank you. So what happens is over here, it prints the. Sorry, I was just here. So what happens is that it prints the name of the speech engine that you're using at the moment. So like I said, at the moment we're using Kinect's American English. That's down here. So you can click on OK. You can skip that and then just move on. So press start and say, okay, feel free.
Should I speak it? Ohrid.
Slow down. And please keep quiet because it's kind of sensitive as well.
Ohrid.
Slow down, people are talking.
Ohrid. Blue.
Try to keep the laughter now. Chelsea.
Green. Green.
Okay, so that was too low. So
Yeah, that's what I was saying.
okay, that's what we're checking. Okay, let's just stop this. So you sit out the front as well. Okay, so like I said, it saves the audio, like, okay, that's audio version 1. Okay, so you can see that a lot of files were saved, and these are all the files that the confidence was too low for. So I'm guessing, I'm not sure yet, I'll try and figure that out. I think the Kinect, you can improve the confidence level. So apart from increasing the gain, what you can do is it can also learn and adapt from what you say. Because I realized that at the beginning when I plugged my Kinect up, I would speak to it, it might not recognize the stuff I was saying, but eventually it started to pick up every single thing that I was saying automatically. So you can play so forth. Yeah. So these are all of the files it didn't recognize, and you can help it. You can use these to, like, the Xbox can analyze these and use it to improve the language database. Okay. Then the last demo that I have is basically the same thing, but I developed it a bit further on. So what happens is that it's a game. You can, well, it wouldn't be a game for us because it would be too simple, but what happens is it sets up, okay, so there's a variable random, a random variable basically, and this is all the same stuff from the other thing, so I'm not going to explain this. Okay, so our database of colors this time is extended. We've added a few more colors. There's red, green, yellow, so forth. The culture is still the same culture, American English, and then this is all the same stuff, and there's now a color generator. So what this function will do is that every single time it runs, it's going to color this circle down here with a different color. So let's say the first time when you run it, it's random, so sometimes it's repeated. So when you run it, it'll set the color to be blue, and then you have to say what color the circle is. And if you're correct, then it adds it to the score and so forth up to 10. So it's all the same stuff from the other one, but just some kind of game logic added to it. Okay. So that's done down here. So what we do is, if the confidence, okay, I think this is important. Okay. If you say something that is unrecognized, it's going to tell you again that I don't understand speech unrecognized. Then you've got the confidence level, and we've set this to okay, let's wait for that. So again, we set the confidence level to 0.8 and above, and let's go down here. Okay. What you need to do is you need to convert. You know, all the colors are saved as RGB. So the computer saves it as maybe red is all 255 for red and 00 for everything else. So you need to convert it from the hex, which is that, which is like actually red 255 so forth. You need to convert it to HTML, and then we convert it to string. Okay. So basically, what we're doing is every time you set a color for the ellipse, which is the circle, you find what color you've set it. So because it's a random thing, you need to convert it down, and then you get to find out. Okay, so in this time it was red, in this time it was blue, and so forth. Then what you do is you compare what the color is to the text that was set by the person. Okay, like I said, this is the exact same stuff from before. So if you guess correctly what the color is, then it's going to tell you well done, and it'll add 5 and 5 to the score and 1 to the round, and then it'll call the color generator function again. So it's going to keep on doing that until it reaches the round 11, which is round 10 basically. So then it'll tell you, okay, you scored this much out of this much and so forth. So let's run that again. We're going to have to be quiet again, and I need a volunteer again. Yeah? Okay, no, that's someone new. It's okay, so silence please.
Blue. Blue.
You need to speak up.
Blue. Red. 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 Green. How do you speak? Red. Red.
Okay, let me stop it for a second. What happens is that I haven't set it, I just made this yesterday and so forth. I haven't set it to hear each word and pause for you and stuff like that. So if you say a stream of words, it's going to pick all of them up, and then it's just going to say wrong, right here. So when you see the color, then you say the
Yellow.
Another mistake.
Orange. 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 Orange.
Big mistake. Okay, but there's a mistake in the game logic when you realize when you click on stop, it has to go back to 0 for the rounds.
Also, I can recommend about difficulty level. You can change the confidence. As an input. For example, it's very difficult. It should go over 95.
Okay, yeah, that's true as well. Yeah. Okay, so that's all to do with the game logic. So, like we just realized right now, sure. Alexander. Okay. So, like you just said right now, you can think of adding confidence level difficulty. So, like an infant, it's true, I didn't think of this. I was thinking of this like a game to stick my cousins in front of. But what you can do is you can set the confidence level, the difficulty, down to maybe 0.5. Because infant won't be able to say some colors. Something like green might come out like green or something like that. Who knows? So you can set down the confidence level, and then apart from that, another mistake that was in the shred now is when you click on button, stop it should set the score back down to 0 and around back down to 1. Okay. So that's basically it for today. Do you have any questions or anything like that? Yeah.
You have access to the sound, the voice recognition engine, and I'm about to put Macedonia for
I don't know. I think you would have to set up your own. You'd have to create your own program and install it. Because what happens is that with this one, it's using a combination of the Kinect SDK, which you've installed, and then the Microsoft speech recognition. I don't know. You've got speech down here. Right. So the normal speech recognition that is built in with every computer. So it's using a combination of these two to improve the language. I don't know, but I think I don't know, Ibrahim. Does your phone, does it work with Macedonian? Do you speak Macedonian as well? No. Okay. Yeah. So I don't think it's just English and German and so forth. Any other questions? No. Okay. Then I'm done for today.